While we consider stars, we most likely envision minuscule, sparkling things in the evening sky. Basically, this is the way we see them from down here in the world. However, stars are something completely different. Little in reality, quite possibly the greatest star, Betelgeuse, is a lot bigger than our Sun. For quite a long time, this star has bewildered researchers. Yet, as of late, another component agitating has been going on with Betelgeuse, making researchers and other well-informed people extremely concerned. Join us in this video as we investigate the astounding news about Betelgeuse, its looming obliteration, as foretold by the James Webb Telescope, and how this new advancement will influence our system and our lives here on Earth. As explained by physicist Michio Kaku, Betelgeuse is a vast miracle, an enormous star that has captivated cosmologists for so long. A Greek astronomer named Tony was quick to find it. This star is colossal to the point that it tends to be found in the night sky from Earth, especially during winter. If you're into constellations, you've most likely seen or heard about this star. It is the rosy-orange star that marks the upper left shoulder of the Orion constellation. So you see, this star is old and is quite possibly one of the most brilliant stars in the night sky. However, one thing about Betelgeuse's brilliance is that it doesn't remain consistent. Rather, it changes. This variation is one of the special properties of this star, but it isn't the only one. Let's check out some of Betelgeuse's specific properties. The vast majority of the stars you find in the evening sky are a long way from Earth. The closest star is 4.2 light-years away from Earth. If you fail to understand how the term light-years explains distance, picture it this way. Consider traveling at the speed of light for an entire year. It's been demonstrated that light can cover a distance of 186,000 miles per second. Thus, the distance light can cover in a year is equivalent to 1 light-year. If you do the math, you'll have billions of miles. So when we say the nearest star is 4.2 light-years away, it means it is billions of miles from Earth. However, some stars are significantly farther, and Betelgeuse is one of them. Betelgeuse is found around 600 light-years away from Earth. So if you somehow manage to travel to it at the speed of light, it would still require 600 years. We can't travel that fast. Not even our quickest spacecraft can. However, this star can still shine so brightly in our sky. If you're wondering how Betelgeuse can be so brilliant despite its distance, that is due to its other characteristics like size and luminosity. Betelgeuse is multiple times bigger than our Sun. Its diameter is estimated to be around 1,000 times that of the Sun. Unfortunately, it appears as a disk in space while using refined telescopes, whereas other stars appear as small points of light. The disk appearance is thought to be an effect of the reactions at the outer layers of its atmosphere. In terms of mass, Betelgeuse measures around 12 to 19 solar masses. A solar mass is the standard unit of mass used by astronomers. One solar mass is equivalent to 2 times 10 to the power of 30 kg. Researchers can't determine the exact mass of Betelgeuse since there are no other planetary bodies orbiting around it to compare, and of course we can't measure it directly from here. The fact that this makes it the world's heaviest star is that it is approximately 12 to 19 times heavier than our Sun. The brightness of Betelgeuse ranges from magnitude +0 to +1.6. In simpler terms, Betelgeuse is multiple times more brilliant than our Sun. No wonder it was nicknamed a red giant. Anyway, the brightness of Betelgeuse doesn't remain constant. It changes. This change is due to its pulsations. In other words, Betelgeuse expands and contracts. When it expands, it becomes brighter, but when it contracts, it dims. This cycle can last anywhere from 10 to 100 days or even more. One remarkable property of Betelgeuse is that its surface is covered in dark magnetic spots. The magnetic field in these regions is far stronger than at the average surface. Yet the drawback is that these strong magnetic spots restrict the flow of hot gas to the star's outer surface, making the star cooler in these areas. The fact that Betelgeuse has many of these spots compared to our Sun explains why it is cooler than our Sun despite its size and brightness. The Sun also has its own dark magnetic spots, but those on Betelgeuse are much larger and quite different. To give you an idea, the spots on Betelgeuse can be twice as large as the Earth. Betelgeuse also boasts a magnetic field that is around 20 times stronger than that of the Sun. This field is why, when viewed through a telescope, the gases on the surface of Betelgeuse seem to be in swirls or curves. Betelgeuse has a surface temperature of about 3,500 Kelvin. This low temperature contributes to the low energy radiated by the star and its faint red color. Betelgeuse is a red star, but it wasn't always red. It was yellowish around 2 million years ago, much like our Sun. Over the years, the color began changing to orange-red, and then around 2,000 years ago, it slowly began turning into the red star we know today. This fact has led scientists to believe that the star is aging. Betelgeuse radiates as much as 100,000 times more energy than the Sun. It would have been a fierce competitor to Earth's Sun if it weren't so far away. Moreover, the fact that Betelgeuse, which is 600 light-years away, can still be seen and identified with the naked eye at night is quite astonishing. Our Sun is only 8.3 light-minutes away from Earth. That's why it is so powerful. If Betelgeuse were even slightly closer, we would also be able to see it during the daytime. However, if it were to replace the Sun, it would engulf or displace Earth and the other 4 planets nearby due to its enormous size. Besides, even if it could match the Sun, it emits more radiation than our Sun. Betelgeuse, also known as Betelgeuse, is a massive star located in the constellation Orion, approximately 600 light-years from Earth. This gigantic size is one of its most striking features. It is 1,000 times bigger than our Sun in terms of diameter and could easily envelop the orbit of Jupiter if placed at the center of our solar system. This colossal size allows Betelgeuse to appear as a distinct disk rather than a point of light when viewed through powerful telescopes. In contrast to most other stars, despite its enormous size, Betelgeuse is not the most massive star. It ranges in mass from about 12 to 20 times that of our Sun. This variability in mass estimate is due to the difficulties in accurately measuring the mass of stars that lack a companion star or other objects to provide gravitational reference points. Nonetheless, even at its lower estimated mass, Betelgeuse remains a significant celestial object. The brightness of Betelgeuse is another important characteristic. It varies sporadically over time, with its luminosity ranging from magnitude 0 to plus 1.6. For comparison, a magnitude 0 star is about 2.5 times brighter than a magnitude plus 1 star. At its brightest, Betelgeuse can be 100,000 times brighter than our Sun. This variability is attributed to its pulsations, periodic expansions and contractions caused by internal processes within the star. When Betelgeuse expands, it becomes brighter. When it contracts, it dims. These pulsations can last from days to months, contributing to its dynamic appearance in the night sky. Betelgeuse's surface temperature is relatively low for such a massive star, measuring around 3,500 Kelvin. This low temperature gives it a distinctive reddish-orange hue typical of red giant stars nearing the end of their life cycle. Like other red giants, Betelgeuse is in the late stages of stellar evolution, having exhausted the hydrogen fuel in its core and begun fusing heavier elements. This fusion process generates energy and causes the star to expand outward. The star's atmosphere is rich in complex physical phenomena. It displays dark magnetic spots on its surface, which are significantly larger and different from those found on our Sun. These spots are regions of intense magnetic activity that inhibit the flow of hot gases from deeper within the star to its surface, resulting in cooler areas on the star's surface. Betelgeuse's history and cultural significance further make it a notable celestial object. Known since ancient times, Betelgeuse has been observed and recorded by various civilizations throughout history. Its visibility in the night sky, especially during winter in the northern hemisphere, has made it a prominent feature in mythology and folklore. Recently, Betelgeuse has garnered increased scientific attention due to its dimming episodes, which began around late 2019 and continued into mid-2021. During these periods, the star's brightness dropped to unprecedented levels, sparking speculation among astronomers about its impending fate. Betelgeuse, also known by its formal name Betelgeuse, is a prominent star in the constellation Orion, located approximately 600 light-years from Earth. It stands out not only because of its position as one of the brightest stars in the night sky but also due to its immense size and variability. This massive star has fascinated astronomers and stargazers alike with its periodic changes in brightness, distinctive red color, and significant role in understanding the life cycles of stars.